This is problem 45 in real 4. Basically, there are 6 people and you need to create 3 teams of 2. All the teams are of 2, everybody is allocated, and these people will study 3 different topics that in this case I chose geography, mathematics and English. So that's an example. You can allocate A, B, C, D, E, F. And they are asking you how many different possible combinations of people studying different things are there. So the basic thing that you normally do is permute the order of people, and you say, okay, well, let's leave this team fixed. And what I do is I just change the order of people. So instead of A, B, C, D, I start with B, B, C, D, E, F, and then I put A at the end, or I start with C, D, E, F. And you can see very simply that there are many different cases. And basically what you're doing is permuting the order of 6 people, all of them. To permute the order of 6 people is 6 factorial. So you kind of know that you have like 720 cases there, 6 factorial cases of permuting order. However, you can see it clearly in my explanation. If a team is studying geometry is D and E, and instead of being in this order, they are ED, is the same team and they are still studying geometry. So these two cases, what I put here is totally the same. The order within the team is not relevant. So for each of these teams, you need to basically get the 6 factorial and cancel for the repetition. Literally for every case, you have another case, and you only want to count once, so you need to divide by 2 factorial for this, and you need to divide by 2 factorials if you're swapping these two, and you need to divide by 2 factorial if you're swapping these two. So it's 6 factorial divided 2 factorial, 2 factorial, 2 factorial. When you compute this very simply, you cancel all the 2's, you end up in 90 options, which is the right result. No problem. So a little thing to consider is important to note that imagine that you have this case, A, B, C, D, E, F. They are studying geography, mathematics, and English. What happens if you swap the order of people and suddenly you end up with A, B studying mathematics and C, D? So basically the teams are the same. A is still with B and C is still with D and E with F. The difference is that now A, B are studying mathematics and not geometry anymore. So it's the same people, but in different teams. That is not repetition actually in this problem, because you know very well that it's not only forming a team, but it's forming a team and studying a specific topic. So it's more or less like when you put them in a football team. If the teams are just teams, there will be repetition here, because the only thing that defines the team is that A is playing with B. But if the teams, they have names like Barcelona, it's not the same to play for Barcelona than to play for Real. Everybody knows that. So because this is different, there is no repetition. These two options are not the same, so there is no need for correction. If there were teams without names, you will have to divide by 3 factorials because you have 3 teams there, and this will turn to a totally different number. Just highlighting that this is tested in GMAT a lot. They will give you teams without names or team with names, things that you're doing, or only just build a team, and they don't tell you that they do different things. Okay. So that's kind of the learning of this problem.